All right. Good afternoon, everyone. So I'm Nicolas, this is Julien, just so you won't mix up both of us. I'm a technical trainer based in Paris. I'm delivering trainings for AWS all over EMEA. And Julien is our beloved technical evangelist for the French region, but he's not really in France. He's all over the world. So today we're going to discuss about running BSD, so free BSD mostly, and a little bit of OpenBSD on AWS, and we thought we'd have some fun with those two OSs. And so this is a little bit about us. I'll start with myself, and then I'll hand you the mic. So I discovered OpenBSD in early 2000, and the Spark Station that you can see here is the first machine I installed OpenBSD on. So this dates a long time ago. And then shortly after that, I was a little bit alone in the being French and learning about OpenBSD. So I started the OpenBSD France community, which I ended, I believe, early this year, by lack of time. Too much things to do. And so I've been learning Unixes in general, starting from the OpenBSD background.
Hi, and I'm Julien, and so I'm an older guy, so I won't actually tell you when I started with open source. It makes me feel so bad. You can guess by the age of my CD-ROM collection over there. I guess most of you were not even born, so that's a terrible thought. And back in '96, I think, I translated this book, which is probably somewhere in your library. Which is the French version of Kirk McCusick's book on BSD, right? And I know he was here a few days ago, and it's a tragedy that I could not even get to meet him because I was traveling. So hi, Kirk, me again. All right, and no shit. This guy. It's the first time we meet. It's a wow. I know I cannot do this presentation anymore. I feel so worthless. Oh, man, you should be filming this guy. Yeah, no, I didn't bring it, but that's okay. You made my day. He's a legend. He's a proper legend. All right, so now we should be really good, right?
Yeah, hopefully.
Okay.
All right.
Okay, so here's the agenda for now. So we're going to talk about the AWS infrastructure just for a bit, just to show you what kind of architecture we have. Then Nicolas is going to talk about instances, virtual machines, operating systems, and we'll start some benchmarks, right? Because it's important to see how fast things are running. And then we'll spend a bit of time talking about, oh, you're here too, man. I know everybody here. Oh, man. All right. Okay, so now I need to be double good, man. Shit. All right. We're going to look at how to build Amazon machine images with BSD. And it's an interesting process. We'll talk about automation quite a bit. And then we'll look at the results of our benchmarks, which hopefully will be complete, right? So don't be too fast, right? And then we'll take your Q&A, and actually we decided we would love to take your Q&A during the session, right, to make it more interactive. So if there's anything that doesn't make sense, anything you disagree with, if you want to throw stuff at us, that's okay. You know, we can take it. We've seen worse. Okay, a word about infrastructure then. So as you probably know, our infrastructure is spread across 16 regions across the world. These regions are broken into availability zones, which are infrastructure partitions that are close enough to allow for replication, etc., but far enough so that if one of them actually explodes, or if a volcano erupts, in Dublin probably, then the other ones should keep running. And we have a whole lot of edge locations, and I'm sure this number is already false. These are the locations for the Cloud Front service, which is our content delivery network, which spans, the globe now. So a region is a number of data centers. And when I say number, the number is larger than one, right? I know some, let's call them competitors, like to call regions one data center. For us, it's much more because we think redundancy and HA is really, really important. So we have multiple availability zones. We'll talk about that in a second. They're fully connected with a very, very low latency network, usually less than 1 millisecond, which really allows us to replicate data, storage, databases, etc., to replicate it even synchronously. So that's one of the regions, and you probably know we're going to open a region in France this year. Yeah, this year, right? So it's between now and December 31st, 11:59 a.m., 59 seconds, right? People keep asking me, they ask me for the date on Twitter all the time, like I was going to say. Yeah, this year, all right? If you want to know more about this stuff, there's just a brilliant presentation from reInvent by James Hamilton, who's one of our infrastructure gurus. I cannot recommend it hard enough. It's legendary too. So inside an AZ, we have multiple data centers, right? So let's talk about the French AZs that are coming. Each AZ will be at least one data center, but in fact, it's always more, right? So the largest AZs could have 6, 7, maybe AZs in the US. There are older regions, higher scale. So each AZ is going to be a number of data centers, and again, they're close enough that you can do synchronous stuff, but distant enough so that if one is broken, or if one has a power failure, or a fire, or a disaster like that, the other one should keep running. And when it comes to network latency, they are very, very close, right? We're very, very low, much, much less than a millisecond. So this shows you that we have a multiple level of redundancy, right? We could lose a data center and not lose an AZ. We could lose an AZ and not lose a region. We could lose a region, God forbid, never happened. And if you had a multi-region design, you probably would be okay. I guess we'll find out when we lose a region, right? Not soon, I hope. And inside the data center, well, guess what? We have racks and servers. That's not really original, except it's all custom stuff, right? And if you want to know more about that, please look at James Hamilton's keynote. He goes into some of the detail for the servers and the routing and the network equipment, etc. It's all custom, everything, 100%. Because we think this is where we have an advantage from a technology point of view and a price point of view, of course, as well. So we decided not to have very large data centers. Of course, we could have much more than 50K servers inside a data center. But if they go too big, then if one dies, the blast radius, the impact on the rest of the system is terrible. So we stick to, I would say, mid-sized data centers, and we build many of them, right, next to one another. Okay, makes sense? All right, Mr. David, your turn.
All right, so let's talk about instances, those virtual machines in the cloud, and OSs. I'll start with saying that we call them EC2. There will not be any EC3 or EC1 ever. EC2 stands for Elastic Cloud Compute. And so those machines are virtual machines based on the Xen hypervisor for now. And then in the future, some things are going to evolve. We signed a partnership with VMware last year, I believe, and things have grown really, really fast. This hypervisor is now available in one of the regions in the US, US East 1, around Washington. And then to run those machines, you need, of course, hardware, but you also need software. And this is where it gets very interesting. You have multiple places to grab, I would say, something called an AMI, an Amazon Machine Image. So an OS template that contains your OS plus some more stuff. By default, AWS gives you access to AMIs on, well, Windows, you have to have those, Linuxes, and then some BSDs, like FreeBSD, for now, and we're hoping to have an OpenBSD soon, very soon. And then, so those AMIs are pretty basic. They only have the OS, latest kernel, latest patches, and all of that stuff. But then you might want to have something a little bit more custom. You might want to add your own layer of security tools, custom kernel and all of that stuff. So you may want to create your own AMI. This is, by the way, one of the things we'll be attempting to do on OpenBSD, using some of the stuff that Antoine Jacuto has been doing in the past. So you can create your own AMI, put all your stuff in there, and then eventually share it with the entire world, which becomes really interesting when you want to distribute your software. In the past, it used to be, floppies, large, smaller, CDs, DVDs, download, and now you can run your own server with the application already pre-installed, so no one can tell you, well, you've done it wrong, right? It's the software editor or the person granting access to this AMI that is making sure that this AMI has all the right configuration, the right tools, so when you boot it, when you boot your instance, everything is running fine. And then, this being said, you might want to make some money with this AMI at some point in time. And then in order to make some money with that, we have a place called the marketplace. The marketplace allows you to sell, quote unquote, by the hour, the license to your AMI, to your software installed on the AMI. So you can either pay a little bit per hour, or you can pay, per agreement on a 1-year term, is the most I've seen so far. So it's pretty interesting. 4 places to get your AMI, and then inside of this AMI you have the software and the OS, and you want to instantiate that on some hardware. So for some hardware, we have a little bit of combinations of hardware. You'll see that in the next slides. And then until now, you had to pay by the hour of those resources. So the compute, the storage, and then some of the network stuff. Starting October 2nd, you will pay on a per second basis, which is very interesting because most of the stuff that you run doesn't require an entire hour of time. Maybe you require 5 minutes and you don't want to pay for an entire hour, so you'll pay for 1 minute, the boot time, and then the rest of it will be the running time of your instance. So this is coming up October 2nd. And this is only for Linuxes. The Windows license had maybe some things to do with it, right? And so you may want to you want to say, well, this VM is cheaper at somewhere else's place, and it's not really the case. You might want to think about comparing apples and oranges. We have, as Julien said, a very broad geographical cover. We also have a bunch of services, an ecosystem of services running with those EC2 instances. There's about 100 services now, going from very basic stuff, compute storage network, all the way up to IoT, machine learning, Elasticsearch, and all of that cool stuff. And inside of a region, as Julien pointed again, we also have multiple availability zones, allowing you to have high availability for your workloads and synchronizing your data between those different availability zones. So let's look at those instance types. The naming scheme is pretty easy. It's the family, the generation, and then the size of it, just like t-shirts. We made it pretty simple, except that sometimes the size goes really, really big. Like this one, may want to buy some sheets instead of a shirt that size, right? A toga party, something like that. So we have GPU in some of the instance families, the G3 family, the P2 family. The P2 is quite exceptional. You have 16 GPUs. It's NVIDIA Quadros, if I remember correctly, with about 12 gigs of RAM on each of these GPUs. So that leaves you quite a few possibilities to compute a lot of stuff, right? If you're looking at memory optimized instances, the R family or the X family, which is the biggest one that we have so far, it's 128 cores and 4 terabytes of RAM with a 25 gig network interface. Again, proprietary stuff that we built below this layer. And we're extending it soon to 16 terabytes of RAM. So if you're running in-memory databases or caches, this is probably one of the sweetest instances to run your stuff on. And then, so the smallest instance is 1 core, half a gig of RAM, and as I said, the biggest, 128 cores, 4 terabytes of RAM. So in those families of instances, you will have to choose something that fits your needs. And ideally, one of the things that we'll try to highlight with Julien across this presentation is that the size doesn't matter most of the time, right?
Don't give away the results.
Yeah. Well, I mean, I'm just, running an urban legend. Size doesn't matter, right? And so, biggest instance size all the way to the most broad family, the T2 family. And you can see the CPUs here are all Intel Xeons. And on those Intel CPUs, you can tap onto a lot of things, instruction sets, P-states and C-states control. A lot of things are available to you just to tweak your application for that. So today, Julien will be performing a few things that he'll tell you about on the i3 family, the C4 family, and the X1 family. So the X1 family, let's dive a little deeper into it. It's Intel E7 Haswell processors. The 25 gig network interface is quite sweet. And then the C4 instance is the second family that Julien will be using. Haswell processors at 2.9 gigahertz. Instead of the usual 2.3 maximum. So that means that we have custom CPUs. Intel is one of the partners that we're working with, and we're buying a lot of CPUs from them. And I mean, a lot, right? So at some point in time, we want to make a market differentiator. We want the same CPU that everybody else can have, but at a higher frequency. And this is about 30% more performance than what you have on regular CPUs, and it's only available on AWS. Okay? Yep. It's 4 sockets of 32.
Okay. And do I see the very same architecture inside my running operating system, so I don't get cache flashes and risky dual sockets?
Yes, you do.
Yeah, actually, the X1 is so it's a multiprocessor architecture with a NUMA architecture. So each socket has dedicated memory, and that's how you get to 4 terabytes and silly amounts like that. And if the OS supports it, we can migrate frequently accessed pages to the closest CPU, right? So if CPU 1 is actually accessing memory from CPU 0 quite a lot, then we can migrate that stuff to the closest CPU, but that requires OS support, right?
Thank you, Julien. The last family that I want to talk about is, the i3 family. i3 stands for I/O, and we mean a ton of I/O with this family of instances. This is the newest generation of instances. It's using NVMe storage, so quite fast, and you can get up to 3.3 million IOPS. 3.3 million IOPS. This is, light fast, really. And then same thing, 25 gig ENI, elastic network interface, available again on this instance. 0.5 terabytes of RAM and 64 cores. Again, custom CPU for this one as well. Lots of promising performance for this machine. So, we have the storage, the compute, the memory. We need to know about the storage. That's, what comes next. This is where we'll store or instantiate our AMI as well. And so we have two main families of storage. We have classical standard magnetic hard drive, and we have SSD drives. For those two types of EBS volumes, we call them EBS for elastic block store, we do have a little bit of advantage. So for example, for the magnetic hard drive, we're looking more at the throughput of those drives, 250 megs per second on the cold drives, and then on the throughput optimized 500 megs per second. Versus on the SSD drives, we have two types of families, the general purpose and the provisioned IOPS. General purpose can burst up to 10,000 IOPS, and you can merge maybe or RAID 1, 2, 3, 4 of them, so to go all the way up to 40,000 IOPS. Or eventually for your databases which require a lot of IOPS, and we could have provisioned IOPS which deliver a constant 20,000 IOPS. And then again, you can RAID 2 of them to get all the way up, or multiple of them to get all the way up to 40,000 IOPS. Obviously, this is probably going to be RAID 0, surely going to be RAID 0 at minimum, because behind each and every one of the blocks that we present for those types of storage are actual, maybe multiple physical blocks, actually surely multiple physical blocks, so that if we lose a hard drive, you don't lose your data. And then one of the questions that I get asked often is that, how do you guys destroy the hard drives? Do you have a special process? Are you, throwing it in the back of the data center and then, eventually moving it somewhere else? Or do you have an actual process? Well, we do have an actual process from the Department of Defense in the US. It's a 3-steps process, pretty easy. First one, demagnetize. Second one, we drill holes at regular intervals, just in case. And then again, just in case, third part of the process, we just shred them. So then you can grow new hard drives, right? Or eventually separate metal parts from the rest. This storage, the EBS storage, is something you have to pay for, but there's another option that is free. We talked about the 3.3 million IOPS for the i3 family. Those are actually the hard drives, the storage attached to the hypervisor. And for the i3 family, again, 3.3 million IOPS up to 15.2 terabytes of storage. But those hard drives are free. Good point. They're really performant. Excellent point. But the storage is not persistent. How come? Right? There's no such thing as a free lunch. This is the thing that I grew up with. So there must be something. Well, when you start your instance on a hypervisor, and eventually if you stop and then start again your instance, you have more chances of winning the lottery than running the instance on the same hypervisor again. So for security and, of course, privacy issues, we won't copy the data from one of the hard drives to one hypervisor to another. So you will lose this data. However, if you can work with that, if you can cope with that, knowing that this storage can be used for maybe temporary files, transformation of files, maybe video, maybe other cool stuff that I don't know about, this is really, really fast. One of our customers, Netflix, you guys may have heard of them. They're using more than 100,000 instances on AWS, and they're not using any more of the EBS drives because of the costs and because of the performance compared to instant storage. And instant storage, again, is really, really fast. I mean, this is, you will see that in a minute, really, really fast. And then it's free, but then again, you have to work with that. So, this is Julien's part. There you go, buddy.
Okay, and thanks for all this information on instances, but they have very different specs, and we want to know how fast they are on real-life workloads. Benchmarking is awesome. Synthetic benchmark can be useful up to a point, but at the end of the day, you want to run a real workload and see what happens. Okay, so that's what we're going to do. So I've picked the largest C4, the largest X1, and the largest i3. And here are the specs again, and the setup. And we're going to build a world on FreeBSD and see what's what, right? So I'm using 11.1 release, which is the AMI available right now on the marketplace. All right? And I think it's faster now with the latest, the latest versions, but the AMI is still 11.1. Okay, so I wanted to run the test that anybody can replay in 5 minutes or so. Okay, so C4, as you can see, has a bit of memory, a few cores, network storage, but I'm using provision IOPS, so I should have a reliable IO level there. I'm using UFS as the file system. X1 has a ton of memory, a ton of cores, and instant store. So I've got about 4 terabytes of local SSD to build on. And for my i3, I've got quite a bit of memory too, a few cores, that new generation of SSD called NVMe. And, well, since I have 8 volumes, I figured I might give ZFS a try. I'm madly in love with the ZFS, so that's my excuse for trying it. And so we're going to build and see what happens. And I also did run those numbers with a RAM disk, and we'll see what's happening there. It's interesting as well. And we'll talk about the price, the hourly price of each of those instances. Okay, so just a few more details before we actually do this. So once again, I'm building on those 3 instance types. For the DX1, remember I've got 2 local SSDs, so I'm using one for USRSRC, one for USROBJ. And I'm going to use all available cores to build. On the C4, I'm putting both directories on the same network volume with the 10K IOPS. That's the simplest way to do it. And again, I'm using all cores. And for the i3, I'm creating 2 ZFS pools for SRC and OBJ and using all cores. Okay, so let's do the setup real quick, launch the benchmarks, and then Nicolas will go and explain how to build AMIs.
All right.
Okay, so
Hold on 1 second. Julien, hold on 1 second just for the thing to refresh. I want to see your terminal. Show me your terminal. It's all black. Probably so. No, not the region. Come on. Ah, there we go.
All right. So that's my EC2 console. As you can see, I'm running my 3 instances there. I'm running my 3 instances there, and I'm going to SSH to each of them, which should already be the case, right? So here's my C4, here's my X1, here's my I3. Okay, so in the interest of time, I've got all the commands ready, but I don't think you're going to learn anything here, right? Most likely you're going to fix my commands. So for the C4, I'm just doing this, right? I'm just extracting sources, which I think I downloaded already, and just go and build world on 36 cores. Okay, so we can just go and do this. Just make sure this is the right instance. Yeah, that should be quite fast. So on the X1, actually I can see, right? I can see my 2 instance store volumes here. Right, XBD1, XBD2, okay. So I'm just gonna, format them, mount them. That should be fast. That's the X1, right? Okay. Okay, and yeah, go C4. All right. Okay, and now I can do pretty much the same thing. Extract sources and build, right? And yeah, maybe you want to see that thing actually happening, right? Well, of course. All right, okay, so C4 is starting to build. And then on the i3, same thing. I can see my volumes here, my 8 NVMe volumes. Here they are, right? And I'm gonna quickly build my pools. Okay. All right, so X1 is building 2. Okay, and same thing here. Okay, so I can see my 2 pools. We're ready to go. Extract the sources and build. Okay, so this is going to run for some minutes, right? I'm just want to make sure this one is actually starting before handing the mic over back to, yeah, so we're on their way here. And yeah, this one, I guess. Oh, yeah. Okay, this one is starting too, right? Okay, so all 3 instances are building. Again, let's show you those, what's happening here? Oh yeah. Just want to show you those specs once again so that you can decide which one you think is going to be fastest, right? And, just, all right, don't lie to yourself, okay? Just Pick one and don't change your mind.
Let's take some bets with raising your hand.
Okay, yeah, okay, who's going for the C4?
Just by raising your hand. Right.
Yeah, come on, just go ahead. I mean, it's going to be closer. It's going to be closer than you think, anyway, right? So, okay, who goes for X1? All right. Who goes for the I3? Oh, okay, so you guys don't believe too much in the C4, right? Okay, so and the rest is pretty much split. So yeah, it's like, yeah, most people are they're split between X1 and I3.
Probably.
Yeah.
Probably.
Okay, but the brave soul has said the C4 would win. Okay, there's always a brave soul. Okay, so that's fine. We need brave souls in this silly world. All right, so it's going right. Okay, so let's switch back to slides, and we can check the results at the end. Okay, yeah, and Nicolas is going into the process of building BSD, Open BSD, right?
Yeah.
Open BSD AMIs. I'm a free BSD guy, like you understood, but okay, come on, we had to be, we're brothers, right? So your turn.
All right. Thank you, Julien. So, while Julien's build world is going on for all of those instances, we'll just talk about building BSD AMIs. I think Laurent, in the back of the room right there, raise your hand, man. Yeah, he had a presentation yesterday, a very nice presentation on how to build stuff with Consul, right, and OpenBSD. And so part of the stuff that you use probably could be taken care of from the marketplace. There's a lot of things available there. But what I want to talk about today is to use a few tools other than just Console, but maybe in complement of Console, like Packer, for example, which is from the same company. Maybe some other tools like the CLI, which is the command line interface, or the Shell CLI, which I really, really like about AWS, or eventually Aminator for other OSs, right, to build your own AMI. And so there's one template that we've shared to build your own CI/CD pipeline. And this is the idea behind what I want to show you, is how we can bring some of the stuff we do manually on OpenBSD up to CI/CD, and then speed up some things and maybe check some more stuff, and maybe use managed services. So for those of you who don't know what managed services are, it's the same thing as what you're doing with the hands, but with no hands, right? It's usually cheaper, it's usually as secure, if not more secure, and it's in a payment model in pay as you go. So if you consume it, just like turning on the light in a room, you pay for the light. If you turn off the light, you don't pay for the light anymore. And that's the idea behind most of the managed services on AWS. So we're going to build an OpenBSD AMI factory. We're going to have a host, which already runs OpenBSD, and has about 12 gigs available. So some room for the AMI that we're going to create, plus about 4 gigs of temporary files, right? Sounds about right, Laurent? Yeah? We're also going to use the create AMI script from Antoine, who basically brings everything together on a local file system, and then with a little bit of magic, pushes it to a storage service on AWS called S3. Again, there will not be any S4. S3 stands for Simple Storage Service. It's one of the oldest AWS services. I believe it's like 12 or 13 years old. And in the Ireland region, it's one of the coolest services that I use. It's about 2.2 cents per gig. And it can also trigger notifications upon the arrival of a file. So if something happens, then poof, I can eventually use this notification to run some code, maybe, do some modification of my infrastructure, again, just as Laurent showed you in his previous presentation. And so here, what I want to do is this. I want to commit my code, and then eventually trigger a service called Lambda. Lambda is a container managed service that runs your code in Java, JavaScript, Python, or C# upon notification. It runs between 100 milliseconds and 5 minutes of time, and the first million executions of that code, or the first million execution of Lambda, is free forever. The second million, 20 cents. Pretty cheap, right? And so here, I'm just needing to run this for maybe a split second to notify my OpenBSD host here to create a new AMI that includes the code that I committed, and then eventually notify me, saying, hey, you know, the new AMI is ready. Maybe you can use it with something called Code Pipeline. Code Pipeline, if you guys know Jenkins, is about the same thing, but in a managed way and very API, AWS, developer services oriented. So once we have this notification, Code Pipeline can then trigger another service, sorry, many services, called CloudFormation. CloudFormation is one of my favorite services, again, just as Lambda and S3, but not my favorite one. And then CloudFormation basically allows you to describe your infrastructure using either JSON or YAML, whichever is your preference, okay? Just like asking spaces or tabs, something like that. We won't do that today, I promise.
You don't know the answer to that.
Yeah, absolutely. And so CloudFormation will then take all of this information, scan it, identify the resources needed to be created first, like network, like security stuff, and then the resources that it can create in parallel. And so you can create your entire infrastructure really, really fast. This can be used for many things. I want to deploy my application in UAT, or I want to deploy my DR with you know, all of that stuff. And the cool thing about it is that every time you create something, it creates a stack that can be either updated with different behaviors, or, well, main advantage from CloudFormation is that it creates idempotent stuff. So the very same thing all the time, things that us humans are most of the time not as good as, you know, services at. Yeah? So once we have this done, CloudFormation will deploy the application in UAT. You will then be able to run some stuff, right? Some of the stuff that we can run, maybe security/compliance tests. We have a service for that called Inspector. If you guys know Nessus, this is a managed version of Nessus kind of thing. We have a different set of tests or books of tests that have been created. And some of them are quite interesting. PCI DSS compliant, for example. So to run this on your application, maybe you want to do load tests. Really like the name of this one. Really cool. It's called Bees with Machine Guns. It's a tool from News Corp. If you guys know News Corp. Pretty good, pretty cool company. And then maybe some other stuff. You want to maybe test load and security at the same time to know if your application behaves the same way with the full load or eventually more than expected load. And then maybe some features. Is it still working? Do I have to have manual intervention or can I do it automatically? So with that, then you have some results and then you can either feed that back to the developer because, hey, you missed out on something here, or maybe the percentage of comments versus the percentage of code is not, you know, good enough. And then eventually things will go well and then you can move on from UAT to production. This is the goal, and then you can use the blue-green deployment methods, for example, with the blue, the existing environment, and then the green, the new environment, so to switch from one to another without interrupting the customer's experience. It's one of the goals, right? I want my stuff to work. So, that said, I think it's this one. Yes, it's where I start to do some demos. All right, so did I do any chickens, enough chickens today so that my demos will run well?
Yeah, it's gonna work.
Okay, so let's, yeah, let's take this one, bloop, and then this, move on to here, and then SSH to my OpenBSD host. So as you can see, this is 6.1, and then, sorry, df minus h. A little bit of stuff going on here. I haven't cleaned my stuff since this morning. Actually, since, you know, an hour ago. Yeah.
Yeah, it's on time.
Just in time delivery. Absolutely.
1 minute before.
So, I could do this all automatically, but I want you guys to see how things are working. And do you have opened this in Atom already? Sorry about this. No, this is yours. Haha. There we go. So there's a lot of... Oh, tu fais comme ça? Voilà. So a lot of information we want you to see. There we go. And this is the stuff that I will be loading. So I'll be exporting some stuff, and then I'm going to add some mirror. I'm showing my keys. I don't like that. There we go. I'm going to set a mirror for Ireland, as my machine is running in Ireland region. Then I'm going to add some cool stuff, clone my repository, make some modifications somewhere here, and then generate the AMI. So let's cut and paste. There we go. Oh, there we go. Sorry about this. Please don't take a photo of my keys. That would help.
It's on Twitter already.
Really?
Bitcoin mining for free this week.
Yeah, okay. Let's remove those keys real fast.
And we're not live, so that's not a problem.
So let's run this. I'm cloning some stuff. All right. Getting the script and creating the AMI. So you've probably seen this already. Creating the storage, creating all of the stuff that I want to. And then once this will be done, I will be notifying the rest of my applications in the pipeline via a service called SNS for Simple Notification Service, right? And it can send a lot of types of notification. The one that I'm going to use is signifying the end of a task to Lambda, so that Lambda can run with the rest of it. So as we're building, this is something that none of you guys have seen before, right? Except my keys. As I'm building, this is one of the things that I want to draw your attention to. This process is working. It's a great process. However, it takes a little bit of time. It takes a little bit of time because, well, some of the tools that we're using are not up to date. Some of the drivers, maybe, that we're using are not giving their best. And maybe this is one of the things that we might want to require you guys for some help. Help us make it better on AWS. There's a lot of things that can be done. We have a slide later on for FreeBSD as well as some of the stuff that we're needing some help on. Yeah, there's a lot of people running NetBSD in Australia on AWS. And there's in the US and in Europe, in Canada as well, we're starting to see a lot of OpenBSD. Thanks to Antoine and Rake, yes, that helped us. All right, so this is being built. Let me go back to the slides real quick. Up, there we go. This is it. So we're at this stage right here. We're pushing the notification here, and then we're building this. Once this is done, the notification will go here. Code pipeline will trigger, launch CloudFormation, and deploy the application. So CloudFormation is quite easy, actually, once you get used to it, but this is only for AWS. One of the services that is dedicated for AWS. However, if you want something that is more platform agnostic, right? You guys have probably heard of a tool called Terraform, right? And this is pretty cool because you use one DSN and then you plug whatever you want behind it and start running about the same thing, again, apples and oranges, in those different environments. I've seen a lot of customers doing this with VMware because it was already there and you bought those very, very costly licenses, so you need to maybe use them at some point. And so yeah, by API interactions, by CloudFormation, you can do stuff inside of AWS or outside of the AWS. I could be talking about Chef, maybe, or Puppet, or Ansible, or Salt, where once your application is deployed, you have different configurations between UAT and production. So maybe you put everything that is most stable, quote unquote, or most non-moving parts into your AMI, and then the moving parts, you can add them later on. Once your AMI has been baked, and once your AMI has been used to deploy and create new instances in your environments, then maybe you can modify the configuration. And then those configuration management tools are really good to do this at a large scale. Because let's face it, I'm doing it with a few instances here, but maybe you could do it for 100, 1,000, 100,000 instances, maybe at the scale of some of our largest customers, right? Yep. Mm-hmm. Yep, you can do that, absolutely. That's a great question. Again, most of the stuff that I'm doing is just a one-shot thing, just to show you how it would run the first time. But later on, you will have to maybe maintain more AMIs, maybe more versions of your application. And think about it, 1 AMI per version of your application. The boot time of a machine is what, 1 to 3 minutes for most of the Unixes? Quite fast. So you can boot that and deploy that with the template that was the version of your application equals a template. So you have a template and an AMI. You can deploy that very easily. And each and every one of the AMIs that you create has a unique ID. So it's AMI dash something, something, something. Something hard to remember most of the time. So you'd have to build some tools, maybe with automation, with the CLI, with some scripts, to have some kind of management of those AMIs. And also, good point, you pay for the storage. So as you create more and more AMIs, you may want to have some automated way of recreating those AMIs very quickly and make the decision for cost as well, right? Because storage or image generation time is going to take more or less money. So you have to take something that is tailored to your needs. Okay? Does that make sense? All right. So while this image is building, it's taking a little bit of time, a little bit too much time, actually. This is why I was asking for some help. Right now, it's about 20 to 25 minutes to build an OpenBSD AMI. It's still reasonable, by automation. It's pretty good, but we can make it faster. We can make it a lot faster. So for that, drivers and tools are your best friends. Back to what I was saying earlier, once you've committed, you bake the AMI, you notify your teams and code pipeline, you deploy in your AT environment and use this new AMI, you test your application, and then once everything is satisfactory, then you move on to the next stage. Yep?
Can you create the AMI locally and then upload it to the storage?
This is what we're doing. This is what we're doing. Maybe Laurent's technique was a little bit more faster than mine, a little bit faster than... Oh, okay. From your experience, how long does it take to build an AMI from Vagrant? With Packer, yeah, sorry. So with different tools, see, we can split the building time in half. I'm sure we can go a lot faster. I'm really sure. Yep. Mm-hmm. Okay, so different techniques, maybe different results, just like...
I mean, you probably need, you don't have to pick one or the other. I mean, most of the time, you want to be on a stable OS, and you just want to maybe rebuild the AMI and add extra stuff. And when there's a new version coming out, then yeah, maybe you want to rebuild completely from scratch. So it's a combination, right? It's a combination, and most of the time you're just going to be deploying your app anyway on the latest AMI that you have. So that's going to be really fast. So it could be just deploy the app, just redo what you were doing, start from a stable OS and build my AMI, or rebuild it completely. All three make sense at some point in your development process.
Right. So the takeaways from this is that DevOps is for AMIs, but it's also maybe for containers. You've seen probably the process resembling some other stuff like maybe Docker or things like that. Try to use services instead of servers, right? So to make up some more time to more to experiment more things, more services, right? And this is clearly going towards DevOps, I know, but this is the way you're using AWS, the most agile way to use AWS. Security, again, is something very important. Again, when you're granting those services to access different parts, we have a service called IAM that I didn't show, sorry, lack of time, Identity and Access Management, which handles users, groups, policies, and roles, which can be assumed by different services or different resources to talk to each other. And along the way, when you're going to build this CI/CD pipeline, you're going to have to use roles and make sure that you use the least amount of privileges for the right amount of actions. Okay? And then last but not least, one of the advantages is clearly to pay by the usage of what you need. One of the services that I didn't show you is called Code Build, that can build your code, and you pay by the time of execution and the number of builds. So quite interesting as well. Instead of maintaining everything together, managed services can help you with that. With that, I'll give you the remote.
Before looking at the results, before looking at the benchmark results, this is how you can help. So if you're involved in the FreeBSD, the OpenBSD community, then helping us improve the speed of those scripts is definitely top of the list. So please get in touch. And if you made the right choice in your life and you're actually using FreeBSD, then oh, it is the FreeBSD rooms. Yeah, I told you. Yeah, yeah. Colin is our hero. Yeah, thank you so much for the hard work on building those AMIs, and he's part of the FreeBSD core team, as you know, and he needs your help on testing FreeBSD on AWS. He needs your help on writing documentation, which is always, so important, and sometimes, the most difficult part of open source. So please help out, and any help that you can provide also on, having one-click, instant everything for FreeBSD would be very nice. Today we have the AMIs, but we would love to have, proper packages, proper AMIs ready to go, with WordPress and whatever people like to run on FreeBSD. Okay, so there's plenty of ways. Yeah, everybody loves WordPress. And so anything that you can do there would be much appreciated, right? So he's there, talk to him, that's the email address, flood him, he needs your help. And, we want to see FreeBSD much more on AWS. Okay, let's look at the benchmark results. So, okay. All right, so let's just look at the numbers. I ran those tests again yesterday. Hopefully it's complete now.
It's still going.
Okay, so that's C4. Okay. C4 is 11 minutes, 42 seconds. Right? So keep that one in mind. This one is X1, 11:38. And now all the guys say, yeah, I won. I knew the X1 was faster. And I3 is under 11 minutes. Right? So, and it's fun because it's pretty much exactly the numbers I did yesterday. So this is what we get, right? So I3 wins, okay? And that goes to show a few things. That goes to show NVMe storage is just insane, right? I knew it was going to be fast, but it's blazingly fast. And you would think, my guess when I did this test was X1 is going to destroy everything, right? Because building is all about CPU, blood and fire and flames and skulls, and it's just, the biggest, baddest CPU wins. But no. And my guess is, when I spent a few hours looking at this build process all over again, is that, and that's don't take offense in any way, but the FreeBSD build process is just not parallel enough to actually leverage those 128 CPUs. There are lots of sequential steps that are just running on a single core, and you waste a lot of time doing that. But I'm not sure it can be helped, but you can actually see most of the time, you just don't see parallelism on a lot of steps, and I think, that's where you would win. Yeah, that's where you would make a lot of speed, and you don't. Yeah.
So the wisdom from FreeBSD 4 and before is 3 make jobs per CPU, and you used 1 make job per CPU. So
yeah, but that's exactly my point. We're not using them. I could have. No. The thing is, no. So we're using. I don't know. I don't know what the maximum number is, But we probably end up using, I don't know, at any given time, maybe 40 or 50 cores in parallel, but we never go as high as 128, right? Because, yeah, please.
So I actually ran these benchmarks this morning because I knew there were going to be tests here. Actually, the X1, if you only run with 64 parallelism, it takes 10 minutes and 39 seconds.
Okay, so I'll try that.
We actually have issues with kernel locking.
Yeah.
We're just spending too much time with contention. There's work in head which improves that. With a head kernel compiling 11.1, we can do it in 8 minutes and 31 seconds. So there's definitely progress happening there, but it's a scalability issue in the kernel, not just with a build process.
So that's what I referred to earlier. I mean, I'm using 11.1 release because it's the official AMI right now, but yeah, it's gonna get faster. So it's it's pretty interesting to see that. Not the biggest instance wins actually. So I run those same tests, exact same parameters on RAM disk, and this is what I get. So I have a minor improvement on C4. I have a small improvement on X1, and I run this repeatedly, and actually I get slower with the RAM disk on i3. And my only conclusion here is ZFS is just brilliant. But that's probably my troll for today. And the last thing is, how much do these cost, right? We pay per hour, and soon we're going to be paying per second. So here are the prices, right? Yeah. So again, it goes to show one thing, is that performance is very nice, but at the end of the day, even if you're going to use i3, right? Would you be willing to pay 4 to 5 times the hourly price just to gain a few seconds? I don't think so. And so that's the advice we give to customers all the time, again and again and again. And Laurent will agree with that. When they ask us, I've got this workload, what instance size, what instance family, what instance size should I pick? The only reasonable answer is, please run your benchmarks. Please run the actual application and figure it out, okay? And then you get that performance level and you decide how much you want to pay for that, okay? So if absolute speed matters, and maybe not for a building, right? Let's agree on this. It could be another application. You could say, yeah, every second counts. So, okay, I'm paying that premium here. But I guess the right price point here for this use case would be C4. Right. So run your benchmarks again. Synthetic benchmarks are nice, but the real testing should happen with the real workload, and then you can see what happens. Okay. As a conclusion, we talked about BSD today, but actually, this is just EOS, right? It's important, but it's just EOS, and then all of our customers on top of that, all of our users, they run a crazy amount of open source, right? And from databases to NoSQL to Hadoop to Puppet and Chef and Jenkins and all the CI/CD tools, etc. And actually, all of these, one way or the other, work really well on AWS. Some of our services are even based on those pieces of technology, like Amazon RDS for relational databases, where you can pick from MySQL and Postgres, etc., MariaDB and so on. So, all of those, one way or the other, we help you run them on your OS, okay? And let's face it, yes, sometimes it's running Linux, right? But, so, we help BSD run better on AWS, but we don't just stop there, right? We really want to have as many open source projects running very well on AWS. So keep that in mind, and feel free to ask questions later on or get us on Twitter, and right. And pretty much that's my conclusion. So thank you very much for listening. And we're really looking forward to have more free BSD and maybe a little bit of open BSD and NetBSD run as well on AWS. Thanks again, and if you have questions, we'll hang around. So please show up. Thank you.